I'm Razib, Director of Scientific Content here at Incytome.
And I'm Gareth Razib, Director of Genomics at Incytome.
And we're here for the weekly snippet, and this week we're going to talk about GMO, genetically modified organisms. Scary. The European Union recently gave some guidance that defined CRISPR gene editing as GMOs. What scientists are pointing out is that traditional breeding, which uses radiation to create mutations all over the genome, is actually much more extreme in terms of how it changes the organism than CRISPR editing because it's so targeted. Yeah. So, I mean, genetic modification happens every generation with mutations normally.
In one wheat field, in a generation, on average, every base in their genome is changed.
The main difference with GMO as conventionally understood is it's human targeted and human guided. It's much more specific and precise than conventional breeding. So it's really strange that people are saying, I mean, mostly what they're saying is, oh, we don't know what's going to happen. It could be super scary.
Why are they scared? They're scared because there's grafts of non-plant organisms inside these foods, like bacterial genes that produce insecticides been spliced into crops.
Yeah, but I'm looking at someone right now who's 10% virus.
Me too.
Yeah. I mean that's the issue. Like, people are scared because there's a frog gene in a tomato. But we have a lot of viral genomes. We have a lot of other stuff in us as well. This is part of nature. Nature is mutating, and we have DNA repair mechanisms to make sure that it doesn't mutate too much, right? Otherwise, we'd have...
So you're arguing that just by traditional natural mechanisms, there's already a pretty significant amount of gene flow between organisms.
Yeah, everyone needs to be cool because this isn't that freaky.
So why do we modify crops to begin with?
Well, you want to make them pest resistant.
Exactly. You want to make them grow faster. You want to make them pest resistant. It's all for the purpose of making food cheaper.
If you look at ancestral apples, they're tiny, they're bitter, unpalatable. If you look at ancestral wheat, the seeds don't fall out. Ancestral maize, corn, as we'd say in the United States, it's tiny. All of the food crops that we have today are mutants. They're huge. They're gigantic. They often went through chromosomal duplications to increase their size. So we are eating genetically modified organisms constantly. It was just relatively slow and inefficient, right? So we are bringing modern technology to a process that's 10,000 years old. All we're trying to say is, like, the European Union is very backward looking here. They aren't moving into the 21st century. That's their choice. Unfortunately, it affects other countries. Say a country in Africa, they have to export to Europe, so they have to make sure that their crops are not genetically modified, even though they would want to genetically modify them because it increases their profits, increases their productivity. But, you know, European Union's a big buyer, and if they don't want it, you're not going to produce it.
So where would you say we lie on opinion on the EU regulations?
It's whack.
Whack.
Yeah, I mean, I don't think you will ever talk to a geneticist who supports the EU regulations because geneticists know the science. The risk is extremely low, and it's much lower than regular breeding processes, arguably. If you do mutagenesis with wheat through, like, you know, exposure to chemicals or radioactivity, that's much more extreme than GMO with CRISPR targeting. So I don't really understand why there's a bigger ethical issue doing a smaller genetic modification than a bigger modification on a plant. You know, genetics for a better world.
It's political.
Yeah. Genetics is political.
See you guys next week.
Power to the geneticists.